Hello everyone. I just would like to see if you can hear me. So if my voice is low or high, please just let me know. Because last time I made a webinar, someone said that the microphone was having a low volume. So I just changed that. So please, if you can let me know if you can hear me well now. Can please someone write me if you can hear me well? Okay, very good. So thanks a lot for joining this webinar. And as I have already explained, this webinar is going to be for speaking about the VRRP, Virtual Router Redundancy Protocol. So of course on MikroTik. So a lot of people they really want to know about what is VRRP and how can we configure it on the MikroTik. And a lot of people think that it is difficult, or they also don't know what is really the function of the VRRP. That's something you can see it here on the MikroTik router. When we go to the interface, we see something like here, which is VRRP. And also you can get it when you go to interface, and also over here you can create an VRRP. So what is exactly VRRP and why we use it, and what is its function? So that's something I'm going to explain it in this webinar, and I'm going also to do a lab to show you how you can configure it so you can have an idea of how you can use VRRP. So VRRP is very important, and I will explain to you directly now why it is important and how we can use it. So let's go to this slide. So let's think that we have this network, all right? We have the internet, which is connected to the router. Normally, that's how the network is. The router is connected to the switch, and my computer is connected to the switch. So normally, when this computer wants to go to the internet, he would go from the switch to the router to the internet. So that's what is normally most of our networks nowadays, right? So now the thing is that, let's think of it. The only way for this computer to go to the internet is from this router. So this is his gateway. So you can see on your computer, you should put here the IP address, the subnet mask, and also the gateway. So the gateway in this case is going to be the IP address of this router, which is this interface over here. So that's the only way where we can go to the internet, correct? That's the only way. But let's think of like, what if this router stopped working or the interface got broken? So yeah, we are in trouble, and we cannot go to the internet. And yeah, believe me, nowadays the computer is just a dump. It's a dump device if we don't use it for the internet. So what can we do on the computer without having the internet, really? So there is a solution here. So the other solution is we come to this scenario and we say, okay, fine. I'm going to put two routers. That is router 1 and that is router 2. And both routers, they are connected to this switch, which is connected to this PC. Then we think that now the PC can go from the internet from this way, and in case this is broken, then he can go from this way, right? But yeah, guys, you know that on the computer you have to put only one gateway. So only one gateway you can put it on the computer. You cannot say on the computer that I want to put the gateway 1 and gateway 2. So that's not possible. That's possible not only on computer, on any network device. You cannot do two gateway from or for the same network device. So putting two routers like this, that you have redundancy, it doesn't solve the problem. Of course, we need to put the two routers, but we need to configure the VRRP to be able for those two routers to agree which one has to pass the traffic and which one will go as a backup. So this is the whole idea. So if we make a simple review, that is how the network looks like nowadays. Now, with this one, we have single point of failure. In case the router is not working, then we cannot go to the internet anymore. The second way is to put two routers, but we have also a problem that on the computer we cannot put two gateways. We have to only put one gateway. And yeah, so how can we do the redundancy? So we have to do gateway redundancy now, or gateway failover, whatever you like to call it. But at the same time, we cannot put more than one gateway IP address on our computer. So what can we do? Then in this case, we have this solution, which is the VRRP. So VRRP, which is Virtual Router Redundancy Protocol. All right. By the way, VRRP works on the RFC 3768. So when you say RFC 3768, that's the standard of the VRRP. Now, what can happen over here on the VRRP? What will happen is the following. You come to the router 2 and you come to the router 1. And you enable VRRP here and you enable VRRP here. You should enable them on the interface Ethernet 2. All right, so you enable them on the interface Ethernet 2. And then you put on your router here the gateway that you would like to reset. So let's say you put the gateway 192.168.123.250, for example. All right, so 250. That is 192.168.123.2. That is 192.168.123.3. So what is 250? So 250 is the IP that you put it for the VRRP. So it's like a virtual router that has been created, which is going to be the gateway for this PC or for the network. All right. Now, of course, this is a virtual router. So that means what? Let's say that when we make the VRRP, this router 2 becomes the master. So this one is the one which the traffic is passing from. So what's going to happen? The PC will send the traffic to 192.168.123.250, which is the virtual router. The router which is virtual, of course, it will send it to the master. That is the master router, and then it will go this way from the internet. All right, so that is how it works. Now, in case something happens to router 2, then directly, so that is down, for example, the interface is down here, so this one becomes the master, and now the traffic will keep going to 192.168.123.250, but then it will go from this way and it will go to the internet. So in this case, we secure to ourselves that we have redundancy on the gateway. And that's the beauty of the VRRP. VRRP, by the way, is an open standard protocol. That means in case you have MikroTik router and you have a Cisco router and you want to configure VRRP, so it is possible because the VRRP can work on both devices, on the Cisco, on the MikroTik, on Juniper, on Huawei, on all those devices. VRRP can work. So that's an open standard. All right. So now on Cisco, they have something called HSRP, which is similar to VRRP. So it has similar function, but the difference is that it is Cisco proprietary. So it only works on Cisco products. So you cannot use HSRP on MikroTik. Actually, there is nothing called HSRP on MikroTik. So this is the whole idea of VRRP. You can see it's not really difficult as an idea. So what you need now to do, we need to go to the MikroTik router and we need to configure that, and we need to do some more things than this explanation. So this is just a basic explanation of what is the VRRP. You get the idea. Based on that, we can do the lab. Now, very important thing to mention about VRRP before we go to the lab, that's I forgot to add it here, that the gateway that you want to use, that you want to put on your computer, which is, for example, 192.168.123.250, that is the gateway that you want to put it on your computer, which is for the one for the virtual. It can also be 192.168.123.2. So it can be the physical IP of router 2. You can still use the physical IP. But then what's going to happen if it's going this way? If this is broken, then it will go from the other way and even though we put in the gateway 192.168.123.2, because 192.168.123.2 is not really this IP, it is really the IP of the virtual router. All right, but you can also use the physical IP address if you want to. Now, on the HSRP, that's not possible. On VRRP, HSRP on Cisco, if you are not Cisco guy, so don't worry about that. But for those who knows about Cisco, on HSRP, you cannot put the same IP of the physical. You have to put an IP which is different than the physical IP address. But on VRRP, that's possible. So you get the idea. Let's just see if you have any question here before I go to the lab. So let's take 1 or 2 minutes. If you have questions, please let me know on what I have already explained, and then I will go directly to the lab. If you don't have questions, then I'll wait 1-2 minutes and then we'll go directly to the lab. So let's see. Any questions, guys, so far? Do both routers need to be connected to the ISP modem? They should be connected to the internet, of course. Both of the routers, they should be connected to the internet. Otherwise, how can they provide internet? So they should be connected to the internet. Any other questions, guys? All right, I think that no more questions. So now, to do the lab, let me just explain to you what I have done. I have already made this scenario. I have my router, router 2, and router 3 that are connected to the internet on interface Ethernet 1. All right, now I have put also here on the Ethernet 1, the DHCP client is enabled. So router 2 and router 3, they are connected to the internet. After that, I have put an IP address on router 2 on Ethernet 2, which is 192.168.123.2. And over here also on Ethernet 2, it's 192.168.123.3. And on my computer, which is also a router in this case, I just made it a router to be acting as a computer, which is 192.168.123.1. So that's it. That's what I've done only on the configuration. And what I've done also, I made NAT, so I enabled NAT on this router and I enabled NAT on this router, just doing masquerade. So that's what I've done only. Okay, I can see that I see some questions. Please let me finish the lab. So do not stop because I have already started that. I will finish the lab, then I will give you some time to ask your question. All right, so let's see what we have at this moment. So this is router 1. And let me put the picture of the lab so you can also follow it. 1 second. I think it's somewhere. Okay, let me just bring it to here, the picture of the lab. Here we go. And I will go small so you can see me more. Then we will have to bring back the picture of the lab. All right, very good. So now let's go back to what we have. So router 1, this is the PC, okay? So if I show you here, if I make export, so you can see there is nothing more, an IP address on the interface, this one, Ethernet 1, and that's it. This IP is just to connect to it via the Winbox. So I only have one IP address on Ethernet 1 on this router, which is acting as a PC. So IP address, there is the IP address, 192.168.123.1. And if I go to tools and I make ping 192.168.123.2, which is router 2, I have a reply. And I make to 3, I have a reply. All right, so this is router 2 and router 3. They are all connected to the same switch. And here, this is router 2. On router 2, I have the IP address, but also I enabled the DHCP client. You see on Ethernet 1, it is connected to the internet. And I made here the firewall. I made NAT because we need to NAT the computer to go to the internet. So you need to have NAT. So that's what I've done on router 2, and on router 3 the same. All right, so let's first check if we have internet on router 2. We do ping 8.8.8.8. So router 2 is connected to the internet. Very good. We go to router 3. Ping 8.8.8.8, and also it's connected to the internet. And both they have NAT, so that means now router 1 can go to the internet. But of course on router 1 we still have to put now the gateway. So what is the gateway that I'm going to use? On router 2 we have the IP 192.168.123.2, and on router 3 we have the IP 192.168.123.3. So if I want that router 1 to go to the internet, if I put 192.168.123.2, then it will always go from router 2. And if I put 192.168.123.3 as a gateway, it will always go from router 3. But what I want to do redundancy. So I want that in case one goes off, I can send the traffic from the other router and vice versa. All right, so now what we can do is we can do the VRRP. So how to configure it? We go to router 2. You can go from here, from interface, and you go to VRRP, or you can just create here the VRRP interface over here. So let's go from here. All right, this is on router 2, a make plus. So here we say the name VRRP, that's fine. This is the type, so I leave everything the same. Now, where shall we make the VRRP? It should be on Ethernet 2. Why? Because if we go back here, let's clear this a little bit. So the VRRP has to be configured on the interface Ethernet 2 of router 2 and also on Ethernet 2 of router 3. So that means the interface which is connected to my local LAN. All right. So let's go and do it. We go again to router 2. So it's gonna be on Ethernet 2. We put the VRID, so virtual router ID, we put it 1. I will speak later about the priority and the preemption. We can do some type of authentication. We will speak about it later, but that's it. That's what I need to do, plus. All right, very good. Now we create the VRRP. We need to put for it an IP address because it is now an interface. You can see it is there. All right, so to do that, we have to go to IP address. And let's make the VRRP IP to be 192.168.123.250, for example. We make it /24, and I put it on VRRP. All right, so this is done on this side. Now we go to router 3. So .50 is going to be 192.168.123.250 is going to be the gateway that we need to put on router 1, which is the PC. So now we go to router 3. Again, we go to the interface, VRRP, we create also the same way. And on Ethernet 2, this is the same. And then I will say, okay. And now we have to put the IP address for this VRRP IP address. It should be the same IP, which is 192.168.123.250/24. And we put it on the VRRP. Now, what's going to happen? Both routers, they will communicate to each other, and then they will agree which one is going to be the master and which one is going to be the backup one. All right, so let's have a look now. We see that this is end up as being a backup. You can see that B is a backup, and router 2 is now the running master. So you can see RM means running master. You can see it also over here. So that means what now? That means that the traffic, it has to go now from my computer here to the switch to the virtual, which is 192.168.123.250, but it has to go from router 2. In case something happened to router 2, and that's something we are going to make some stopping of we block the interface over here, we see that the traffic then it would go from this one. So this one is a backup, and this one is the master at this moment. Okay, so let's do that. Now we need to check if the router, which is the PC, is able now to go to the internet. All I need to do on this PC is to put a gateway. So we just make an IP route, which is like a gateway, and we say to go to anywhere to the internet, go to 192.168.123.what? remember that this should be 250. All right. Yeah, that's it. So let's check if everything is configured good before we fall into problems. And I have problem because I'm doing this online now. So let's check that again about the IP addresses. IP address, we put 250 for VRRP on router 2, correct. Also IP address, we put this one also is correct. So very good. Now let's go to router 1 and let's try to go to the internet. Ping 8.8.8.8. And we can't go to the internet. So something is wrong. Let's have a look what we have as a problem. IP address 192.168.123.1, and we put the route to go to anywhere. Go to 192.168.123.250. This should be okay. Let's try now again. All right. Let's go to the router. I think there is something I'm using now, the GNS3. Could be some problem. Sorry guys. On the GNS3, but let's have a look on router 2. We go to IP firewall. We have the masquerade is there. And let's check this one. To ping it to the internet. Oh. So router 2 is not able to go to the internet. Why that? Let's check the DHCP client. Oh, there's some problem here. Let's open again Ethernet 1, DHCP. Alright, so we have a problem. This is not expected to have it, so yeah, this is connected to the right one. So let's check the other router. Let's check the other router. IP DHCP client, so this is bound here. And if this can go to the internet, 8.8.8.8. So this one can go to the internet. I'm not sure why this router is not able to go to the internet. Let's try again. Alright, what we can do, we can put ourselves an IP address on Ethernet 1. 10.0.0. Let's take some 58 for example. On Ethernet 1. And then from there we have IP route to go. That is the gateway of the internet. Now let's try. Something is not okay. Interesting. It cannot see the gateway, so I have to check my GNS3 and now again, and let me just remove the cloud. 1 second guys. This was not expected to happen, but yeah, problems can always happen. So I will put a new cloud. And then I'm doing that on another screen, so you don't see what I'm doing now. But what I'm doing, I'm just putting a new cloud on GNS3, so this can work again, and I hope it's gonna work now. Let's have a look. If I say here DHCP client on Ethernet 1, yeah, now it's fine. Now it's fine, but this is received, that's fine, and IP address, I'm gonna take this out, and now ping 8.8.8.8, Oops. It's going for the internet. Very good. So now let's go back to router 1 again. Sorry guys for this. This problem can happen. So let's go to router 1 again now and try to ping 8.8.8.8. It is able to go to the internet. Okay, so router 1 has a gateway, the 123.250, and is able to go to the internet. And if we make now tools, if we create tool traceroute 8.8.8.8, so we can see how the traceroute, let's make it on the tool is better, I think. So from here, if we make traceroute to 8.8.8.8, we can see how it's going now, and you can see it's going via 192.168.123.2. 123.2 is what? 123.2 is router 2, correct? So, and that's what it's showing up for us here, that router 2 is, if we look now on the interfaces, that is the master one. So that means now what? The traffic is flowing from this side, like this. From this side. Now what I'm going to do, I'm going to go to Ethernet 2 and I have to disable it. And then I will see if this router can go to the internet from router 3. So let's go to router 1 now and let's open a ping. That is the ping. And I will make ping to 8.8.8.8 from router 1. Now the ping is working, it's passing via router 2. Correct? Let's go now to router 2. And on router 2, I will go to the interface and I will disable Ethernet 2. Boom. We'll go to router 1. Look, 1 request timeout, 2, 3, and then internet is working again. Yeah. Very good. VRRP is working, guys. So you can see the internet is working. Now, let's see how it is going now. We go to tools and we go to traceroute. And before it was going via 123.2, now it's going via 123.3. You can see that, guys? Yeah, that is what VRRP is. So now if I go to router 3, you can see now router 3 became the running master. RM means running master on VRRP. So it became now the running master. Now let's put router 2 back and let's see if it go from router 2 again. So I will bring the interface up on router 2. I will do it behind the scene on the command line because I have access to the command line on GNS3. So interface enable and then ID interface enable number 1. All right, so now router 2 interface Ethernet 2 is back. So let's connect to it again and let's see. You see Ethernet 2 is back. But do you think that router 2 will be the master or it will remain router 3 the master? Let's have a look. We go to VRRP, look, it is back up. Router 2 is back up, while router 3 is the running master. You can see that, master. So that means what? That means the traffic was going from router 2 for the internet. Once router 2 went off, the traffic is going from router 3. Now, router 2 come back, but the traffic is still going from router 3. And yeah, it doesn't make the change unless you do something, and that's something I'm going to show it to you right away. So you need to play with something called over here the priority. All right, so we are on router 3. Let's show you over here on router 3. If we go to VRRP, you have the priority and you have the preemption mode. The priority, you can play with it from 0 until 255. When the priority is higher, then it is better. All right, the higher the priority, the better it is. By default, it is 100. Now, when it is 100 here and it is 100 here, then it is the same. Then if one goes down, and the second is the one passing the traffic, if this one comes back up, nothing will happen. It will still go from this side, unless you change the priority. All right, but also the preemption. Why you need to change to enable the preemption? The preemption means that check the priority right away, and if the one has a higher priority, then let it be the master. All right, so that's why you need to enable the preemption. So what I want to do now, I want to go to router 2. This is router 2. I come here and I make the priority for router 2, I make it 150, which is higher than router 3, which is the priority has 100, the default one. And we have preemption enabled on both. So now the traffic is going now via router 3, but router 2 is back online. I want once router 2 comes online that it always let the traffic pass via him. All right, I hired the priority, preemption mode is enabled. I make okay. Look now directly what's gonna happen. The two routers, they are going to communicate to each other, and in a moment we should see that router 2 is going to be the master. And here we go. You can see running master. So we just hired the priority. We have the preemption mode enabled. Now the traffic is now flowing from router 2. And if you want, you can justify that. So let's start here the ping. You see the trace route, it's going now from router 2. So that's the beauty of VRRP. If you think that you have one router that you wanted to always let the traffic pass via him, then in this case you can play with the priority and you enable the preemption. All right, so that's done. Now the last thing that I want to speak to you about before I start looking to your questions is that I said to you that instead of using the, if we go back to the graph, instead of using the IP, which I put it for the virtual router, which is 192.168.123.250, instead of using this IP, we can use any of those physical, which is .2 or .3. So what I'm going to do, I'm going to use, instead of 250, I have to make .2. All right, I use the physical IP. But of course, we need to change that on the both routers, on this router and on this router for the VRRP interface, but also on the gateway from this router as well, we have to put it .2. And let's see if it's gonna work for us. Okay, very good. Let's do that. We go to the, we start first with router 2. This is router 3. All right, fine. We go to router 3 first. IP address 192.168.250.2. .123.2. We put it .2. We go to this one, and then IP address, we make it .2. I saw some error there. Let me have a look. Oh no, that's gone. All right, so both are .2. And now we go to router 1, and over here the gateway should be, instead of 250, it should be .2. Very good. So let's try now. We make ping to 8.8.8.8. It is working, and we make here the tools trace route to see how it's flowing now. It is going from 192.168.123.2, which is the physical interface in this case and not the virtual. So that is really the IP of router 2. Now let's go to router 2. This is router 2. I will go over here. This is router 3. Actually, this is router 2. Router 2, I will go to the interface and I will disable Ethernet 2. So the traffic was passing from router 2. I will disable Ethernet 2 completely. We go to router 1. We make trace route. Look, it is going from 192.168.123.3. But remember, the gateway is .2, but this .2, which I put it, is not really the physical IP address that is on router 2. It is just an IP on the virtual router. But of course, now the internet is working, so we make ping 8.8.8.8. You can see the internet is working, and it is going via router 3. So that means that you can also on VRRP use the IP of the physical of any of those routers, you can use it, the IP to be the one for the virtual, and it works very well without any problem. So yeah, now let's do something less thing that I want to do. Now the traffic is going via router 3. Let's go to router 2 and enable the interface again. So I will enable the interface. We go now to router 3, we go to the interface. It is running master, but here we go. It went to backup directly because I enabled router 2, the interface on it, and router 2 has the priority higher. So now if we go to the interface, you can see that this one is the master. And that's all what I needed to show you in this webinar. That is all about the VRRP. So I have taken many cases just to show you that how the VRRP work. So now let's have some minutes for your questions. Let me just see your questions, and then yeah, I can answer them. Now, before I do the questions, I just want to say something because this is also interesting to know. Also on the same scenario we have, on the same scenario. So now everything is working fine. Yeah, so everything is working fine, and the traffic over here is flowing from this side, right? That is what we have seen. But what if the router, the Ethernet 2 is still working, but what if the internet works over here, so on the WAN interface? Then we are still sending all our traffic from here, but we are not able to go to the internet, right? Because the internet has stopped. So we are in a problem, right? So what can we do in this case? So here there is something, maybe I will do another video speaking to you how you can solve this problem. But over here we can play with some scripts or something like this. And then in this case, once this is down, then we can run a script that the failover can happen to the other router. All right, but this is something I'm not able to speak to it about it today. All right, so now let's go to your questions. All right, I have to scroll up a little bit to read if you have any questions there. So okay, guys, any questions? So I didn't see really questions so far, but let's see if we have any question here. Is the two router must have the same config firewall rules? No, it's not necessarily. You can do whatever as configuration on the routers. The only configuration that needs to be the same is the one for the VRRP, the same as I have showed you. So that's what you have to do. Any other questions? So let's bring the big video so you can see me better. So I don't see that there is other questions. Anyway, so thank you very much for your time, guys, the time that you have spent in this webinar. And sorry for the small problem that happens. It is GNS3 that I was doing, so it's an emulation. It can happen, the problems. Now, I'm just would like to tell you that until end of October, you can have you can buy one course or more than one course on my website, mynetworktraining.com, and you can get one. So buy one get one free, and if you buy two, you get two free. If you buy three, you get three free. So you have time until end of October. So we have 1 day plus in case you are interested in that. And I have a new CCNA course, Cisco CCNA course, where I also speak about HSRP on Cisco as well. So also you can buy the course if you want, and then get another course for free. All right. So yeah, that's it. I think there is no more questions. I thank you very much for your time, and I hope that we will be doing more webinars together. And I know that many of you have spent already a lot of hours with me on the courses, and maybe a lot of a lot of people, a lot of you know me more than I know you because I don't see you. But you may know my way, you know my explanation and how I can provide the information to you. So thank you very much for the whole time that you are always spending with me on my courses. I appreciate that, and I hope also that you continue learning from me for these courses that I'm building and for the future courses as well. So thank you very much for your time, and I will see you in some other webinars. Bye bye.